Hi, so today we'll be demoing our data visualization model. This model is per the request of a client from our new product lab class. The intent of the model is to optimize channel distribution for our client Calphalon using Simmons data. So what we were able to do is go into the library database, and as you can see, we pulled numerous records for Simmons data so that we could do a couple of things. The first thing is develop sort of a sizing model for a target population. The second thing is eventually develop a sales forecast. And the third thing is to maximize profit based on sales distribution. The fourth thing is to pick a pilot location based on geographic optimization. As you can see from Simmons, we were able to pull some demographic and psychographic characteristics for a number of channels that our client Calphalon uses. So we'll start here at the top. We segmented the target customer base into different types of users. Types of users are important based on the type of product that you're manufacturing and marketing. So the types of users we've chosen to display here are heavy users, at least moderate users, at least slight users, or all users. And we can pick from a number of demographic characteristics, and I'll show a couple of those right now, in order to display some information about different types of users. And what the graph is showing us by channel, on a gross basis, are at least moderate users of this first combination, and moderate users segmented by income and employment. So one nice thing about this model is we're actually able to look at combinations of variables. In this case, we're looking at males who are at least college graduates, so the combination of sex and education. One obvious limitation is that this only goes 3 levels deep. A moderate user, who's a male, who's a college graduate. There are 2 problems with going any deeper than that. The first being that the data sample becomes significantly small and statistically insignificant. And you're able to do, at any given time, 2 different combos, so I could activate this other combo, and any number of demographic or psychographic characteristics. For simplicity, I'll only look at one combination on a gross basis, males who are college graduates. And I can choose to either look at these numbers. So I can look at this on a gross or percentage basis. Another thing that I'm able to do is rank these retailers and give a score based on a weighting parameter. Right now I'll use default weights, but I can also change these weights, and I have an option to do so through this little pop-up menu. I'll leave it as default right now. If I switch back over to gross, I can actually load this data into my list of segmentation or segments. In this case, I have 8 segments, and I'll choose to load a couple of different department stores, a couple of specialty retailers, and a couple of mass retailers. So if I hit record, you'll see over here that I can see what combination I selected, and also for what channels, and actually the size of the population for the target within that channel, to give a total target population. So that's nice, and the next step is we're using the classic ATAR marketing model to eventually come up with a pre-adjusted sales forecast. There are a couple of things that factor into this model. The awareness, percent that'll try, and repeat measures, so how many times person buys per year, are actually hard inputs or hard coded user imports. And the percent availability and profit we'll touch on the next tab, because those are things that are directly impacted by the channel optimization. If we go to the channel distribution tab, we can see that our target populations by retailer and by market vertical have been loaded into this chart, coming up with total target populations by vertical or type of store. There are a couple of things that we have to consider when developing this line item, which is the optimal channel distribution. The first thing is the average profit margin for each of these different types of retailers. Intuitively, specialty retailers have a higher profit margin than mass retailers. The other thing is how people normally buy. In this case, we're saying that for whatever item we're choosing, 60% normally buy in mass. This will dictate how high we can stack the channel. And that's the maximum distribution. This acts as a constraint for the end goal of maximizing profit. This is the highest that we can go in terms of distribution for this channel. There is one complexity, and this is due to the fact that Calphalon's a premium brand. There's an interplay between the channels. For example, a specialty consumer may be less inclined to buy the Calphalon brand if Calphalon maxes the mass channel. And so there's sort of this elasticity of demand column that's going on. And obviously the end goal is to maximize profit considering all of these parameters. So if I reset our solver function and calculate, you can see that based on these parameters, it's giving me an optimal distribution. So the next logical question is, how high does this target population need to be in order for me to justify a full distribution in the mass channel? And that's what these Find Max buttons are for. And so I'll let that calculate. And this is simply using Visual Basic to run through a loop. And you can see that almost 3 million people are needed in order for me to justify maximum distribution within that channel, keeping all of the other numbers the same. So the fourth piece of this leverages many of MapPoint's functions in order to develop a list of pilot locations. Below you can see that I can choose to display any of these channels within a chosen city in a radius of my choosing. In this case, I picked Atlanta, Georgia, and a 20-mile radius. I can choose to export this information to the clipboard. This also does have a calculate distance function, which uses MapPoint's routing function to calculate the distance between the center of any city and any branch for any one of these channels that I choose. We actually did load all of the locations for all the different retailers into the model, and I won't show that right now because it is sort of timely. So if I export the information to the clipboard, the information that I just stated will display in MapPoint. As you can see, all locations within this radius for the various channels are displayed. I've chosen to have this window actually stay open because of the resolution problem when pasting it back into MapPoint. Another option that I have is to find the top 3 addresses within each area, and you can see that they're displayed below by channel. The next large question is how to find an appropriate city to launch the product in or do a pilot. Simmons also uses the same demographic and psychographic data which we have tracked across the model in order to create a list of top 14 demographic metropolitan areas. As you can see in this case, San Francisco, California is the best match. So perhaps I want to change this chosen city to San Francisco with a slightly larger radius. Another nice feature, just because the information was available, we can look at this same information by state. So in conclusion, this is a nice model to develop both sales forecasts and to analyze the impact of shifting goods from one channel to another, and it can also find appropriate pilot locations based on the channels available.